Hello, 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 testing, testing, testing. Hello, 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 testing, testing, testing. Hello, 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 testing, testing, testing. Hello, 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 testing, testing, testing.
When I say that this video is probably the most important programming video you're ever going to watch, it's partly because what I'm going to tell you is distinctly a minority position among programmers. It's probably 5% or under programmers will tell you that definitively
Okay. I'm trying to figure out if this is going to work or not, or how I would go about doing it, so just try to bear with me for a minute here. Hello. Okay, so just a heads up here, I don't know exactly what I'm doing or how this works, so try to bear with me if any of you are more familiar with this format. I'd be happy to hear if you have any recommendations or ideas, but I think we'll figure this out. So I'm trying to figure out how exactly this stage thing works. So if anyone wants to talk about anything, I guess do the hand raise thing maybe. Yeah, we'll figure out as we go, and if it's not working, we can jump into a regular voice chat room. So what I wanted to go over today is there's this video, and I really love this video. I'm not trying to hate on OOP. I know a lot of people really like it, especially if you're working in the .NET ecosystem or if you're doing game development. I think it makes a lot more sense to use object-oriented programming. But a quick little background. I'm sure some of you have heard me say this before. When I started at the company that I'm currently with, all of the code was written in an object-oriented style. The two developers above me left, and I got pushed into sort of a lead position way before I was ready for it. And then when things started going wrong with the projects, I went through hell trying to debug them. I eventually got permission to just rebuild some of these applications, and I found that I was much more productive rebuilding it from the ground up as opposed to debugging someone's old OOP code. And that's not because I think OOP inherently sucks. I think it's because OOP that isn't done well is really hard to maintain. And that would be things along the lines of abstractions for the sake of abstractions. So, for example, you might have, let's say you have a to-do list, and you have a function for add to-do or remove to-do. Now, if you decide to wrap this in a class called to-do task handler, and then you need to instantiate that object every time you want to work with it in a new file, it's a little bit of a headache. It's a little bit more overhead than maybe you need. You might not need a constructor and private or static or you just don't need all of that stuff most of the time. So what it felt like to me when I was working on this code base, it felt like things were abstracted that didn't need to be abstracted. I felt like it added a lot to the complexity, and then the names stopped making sense. And what I mean by that is, let's say that we had a class that said add user. And that name might have made sense originally, but as the application grew and as the needs of the company started to change, this add user class started having a bunch of things in it that weren't just for adding a user. It was a whole bunch of things that came down to user management. So now, if you need to change someone's email address, how are you supposed to know that the add user class is the one that has the methods that you need? So these are some of the pitfalls that I was personally noticing. But what I really love about this video is that, well, for one, when I first started programming, I understood very little of what this video was saying. And now that I'm doing this for a living, I feel like I can relate to and understand everything that he talks about in this video, and it makes me feel good. It reminds me how much progress I've made. I think that if you're a fan of object-oriented programming, I think that this is an excellent video because it also points out where does object-oriented programming go wrong, and I think it gives you a good perspective on what you can do to keep your OOP code more organized and clean, and to create your classes and your relationships with purpose instead of just nounifying your verbs, as he says. So I think it'd be interesting to watch through this, but I need to make sure that, for one, that the audio is working. I need to also make sure that that you guys are able to communicate with me, because I would really love to sort of debate some of these issues. Or if you don't understand something, I'm happy to pause the video and maybe really quick draft up some examples, or any number of things. This really isn't for me. I'm hoping that some of the less experienced people in this server can get a little bit of perspective by watching through this and discussing it, and maybe digging into some of these topics a little bit more. This particular video, the thing that I really love about it is I think that this content creator, Brian Will, I think he's incredibly good at articulating his ideas. I think his ideas are very well organized, very well structured, and very easy to follow. And if he talks about something that you don't quite understand, I don't think it's going to be a big problem, because I think he gives a lot of really good examples, relating it to, what's the word I'm looking for, where you compare something to something else. Metaphor. He gives some really great metaphors that I think make this just extremely digestible. But with that said, let me make sure on the technical side everything is actually working here. Is there some sort of chat here in Discord so I can see? What do you guys think? Should we jump into a regular voice room instead of this stage? How could you even tell me that? I can't hear any of you right now. I'm going to share this link as well. Okay, here we go. I'm seeing something. Hey, how's it going? Can you hear me? Can we hear you? Melvidier?
Okay, sorry, I had to accept to speak. Sorry about that.
Oh, it's all good. Yeah, and thank you, by the way. I really appreciate the advice and recommendations and everything. And I really like that you have .NET experience, because I'm so far removed from it. So that's awesome that you joined.
Oh, thanks. Yeah, you're definitely going to round out my JavaScript side, my client side stuff as well. Yeah, I think we should move into where everybody can kind of interact a little bit more, because if somebody here, I think the video sounds fantastic, but if somebody here has a question or whatever, I don't think there's a way to express that.
Absolutely. I think that's a good idea. So guys, let's jump into the voice chat channel called Open Livestream, and then I'm just going to share a notification with a link to the YouTube stream. And then if anyone can't hear it, or if there's any issues, someone just please let me know, because again, I have no idea what I'm doing here. So yeah, I think that's a good idea. We'll jump in there now.
You obviously have a nice mechanical keyboard too.
No, I'm using a MacBook Air M1. It would be,
okay, well, sounds like you're typing with purpose.
I guess I am. All right, so open live stream. All right, so the last thing I think I need to figure out here is I need to know if you guys can hear this video. So I'll start playing the beginning of it. And if one of you could let me know if you can hear this or if I need to mess with some settings, I'd appreciate that.
Object-oriented programming is just not a good idea, and in fact is going to lead you astray.
We can't hear it.
You can't hear that. Okay.
We can't hear it.
Okay. All right.
We can.
Oh, you
Yes.
can. Okay, got it. Thank you for letting me know. Before we get started here, does anyone have any thoughts about OOP? I'm really curious how, what the general sentiment is here.
I typically, we have certain ways of coding, and I'm honestly here because I'm curious to see what I've used in the past 5 years is how it relates to OOP, because I just don't know the vernacular as well as I should.
Okay, and you said you work primarily with the .NET ecosystem, right?
.NET, C#, yep. Do a lot of APIs, data distribution, SQL stuff.
So obviously you don't have to write C# in an object-oriented style, but I think that's sort of the default, is to have classes and methods instead of having functions. Not that that necessarily makes it object-oriented, but I feel like it really kind of nudges you in that direction.
Well, we like to have a single use principle. So when you're talking about the user or add user, for like emails and stuff, I mean, we would have, like a user controller and then have different, we just have completely different things for that entirely. And so I can see how it gets confusing real quick. So I'm trying to see how that works in OOP.
Okay. Well, very cool. So I'll start playing the video. If any of you have any questions, comments, you want to debate anything, whatever the case is, just unmute yourself and jump in and share your thoughts. So I think this should be interesting. And again, I want to reiterate this one more time. I don't have any problem with OOP. I just personally prefer not to use it, but I think this is just a really great video about programming paradigms in general. So if anyone has any questions, just jump in and let me know.
When I say that this video is probably the most important programming video you're ever going to watch, it's partly because what I'm going to tell you is distinctly a minority position among programmers. Probably 5% or under programmers will tell you that definitively object-oriented programming is just not a good idea, and in fact is going to lead you astray. Maybe you'll have another 20-30% of programmers who will hem and haw and say that it has some virtues and some weaknesses and it might be better applied to some problems than others. I'm not telling you that. I'm telling you definitively, no, object-oriented programming doesn't fit any problem, and you shouldn't take it seriously. This is almost certainly not what you were told in school. If you attended a programming course in the last 15 years, or you read most educational materials about programming, the pervasive default assumption is just, well, object-oriented programming is the right way to go, and it's just a settled matter. So I reiterate, this is probably going to be the most important video you watch about programming, because it's going to tell you something you're not going to get from a vast majority of other sources.
One thing I should probably say before we get started here is that if you don't know what object-oriented programming is, because I know we have a lot of newer developers here, the way that you could think about it is object-oriented programming is the idea that all of your code should sort of be represented in terms of objects, and these objects should communicate with each other through messages. So, for example, you're going to encapsulate. Let me actually think of a real life example here. The to-do list, like I was talking about earlier, you might have an object, and let's think of this object as a class. So what a class is it has your data types, and then it has a bunch of functions associated with those data types. So for a to-do list, you might have one called modify to-dos, and then the data types in there might, for example, be the index or the ID of the to-do that you want to modify. It might be that you have a method, which is just a function encapsulated within a class. That function might be to change either the name or the status of one of those to-dos. And then in order to use it, you need to sort of instantiate that object or instantiate that class, and then it creates an object that you can then call those methods through. So it's a level of abstraction and encapsulation around all of the different parts of your application. So if you want to, again, the previous example, if we want to add a user, like if someone wants to sign up, we don't want that code to be mixed with our code that's also managing the to-dos for our to-do application. So it's sort of the idea that we have a hierarchy of objects. Each object is responsible for doing exactly one thing, and these objects communicate with each other through sending messages back and forth.
First off, I'm going to try and make clear exactly what I'm complaining about and what I'm not complaining about. And then I'm going to try and explain, well, what is object-oriented programming really? Because if we don't nail that down, it's almost impossible to criticize. And then I'll try and account for, well, if object-oriented programming isn't good, why does it dominate the industry? That's kind of an important question, actually. And then I'll actually get into, well, why does object-oriented programming not work? What's bad about it? And then lastly, if I'm telling you to not program in an object-oriented style, then what do you do instead? What is the alternative? It's called procedural programming, but what does that look like exactly? So what are the problems with object-oriented programming? Well, first off, the problem is really not classes per se. That is, I think it's actually possible to program occasionally with classes in a way that's fairly benign. I don't think it's particularly beneficial, but for aesthetic reasons, it might seem more pleasing to have an explicit association between certain functions and certain data types.
Oh, I'm sorry, guys. Can you not see this? Let me share the screen with Discord. I was completely unaware of that. And let me also, I'm also going to end the event because, screw it. Oops, cancel. Okay, yeah, so you guys can't see the screen, right?
We cannot.
All right, let me share that. Okay, how about now? Is this working? Can you see the screen?
Good. Yes, it's good now.
Okay, awesome.
Doing this pervasively, though, as I'll make clear, is a really bad idea. That's where everything goes wrong, is when you try and shove every function of your code, every behavior, into an association with a data type. That leads to disaster. Secondly, I don't think the problem with object-oriented programming is about performance. I recommend you watch this talk by Mike Acton called Data-Oriented Design in C++. He makes some very interesting points and provides some insight into that world of programming, which most of us don't do. But I think he overstates his case. Fine, there's a lot of software out there that should be written with much more regard for performance, but I think there's tons of software that just really doesn't apply. You'll also hear complaints about excessive abstraction from generally the same people like Mike Acton. And again, here I think they're overstating their case. I think abstraction is actually a worthy goal. In practice, most abstractions aren't good. It takes a long, long time to develop good ones. And as I'll explain, a major problem with object-oriented programming is it does tend to produce abstractions that aren't any good. That's the real problem, not the idea of abstraction itself. Another interesting talk to watch is one by Abner Coimbray called What Programming is Never About. And the thing which he says programming is never about is code prettiness, how code looks, aesthetics. His main point is that programmers typically focus too much on surface concerns about their code, rather than stuff that really matters. I think, though, he actually simply misstates his case, or rather his thesis doesn't really follow from his arguments, which are generally valid. I think when really pressed, he would admit that elegance, simplicity, flexibility, readability, maintainability, structure, all these things you might file under code aesthetics, I think he would admit actually do matter. But I think the more accurate way to spin his point is that these surface-level virtues of code are good things and actually important, but object-oriented programming and abstraction-heavy programming in general fails to deliver them. In fact, it provides just the illusion of these things. Object-oriented programming is sold on the basis that it supposedly provides these things, but particularly simplicity and elegance, it actually makes things worse. Lastly, be clear that I'm pushing procedural programming, not necessarily functional programming, which is a different thing, as I will make clear in a moment. I happen to think that functional programming actually is the future of higher level code. I think it may actually be the default way we program at a higher level in 10 years from now or something. But there are serious efficiency problems that make functional programming not really viable in certain domains of programming. And so my message is, whether your code ends up functional or imperative, that's a separate matter. Regardless, your code should be procedural rather than object-oriented. So it's a good time now to make clear exactly what are the competing paradigms of programming that we're really talking about. There are four main possibilities. Your code can first be both procedural and imperative. Procedural meaning that you have no explicit association between your data types and your functions, your behaviors. And imperative meaning that we just mutate state whenever we feel like it. We don't have any special handling of shared state, which can cause problems as your code gets larger and larger and more complex. But in procedural and imperative programming, we just cope with the problems as they arise. And you can think of this style of programming as being basically the default. It's the obvious way to get work done. So this is really how all programming was done in the early days of computers. But then starting in the 60s, as programs got more and more complicated, people began thinking about, well, how do we solve this problem of shared state? Because it really can get out of hand. And so we got two major prescriptions on how to handle the problem. One of these prescriptions says that our code should be procedural, yet functional, meaning that all or most of the functions that make up our code should be pure. They should not deal with state. And so programming in this style, we would tackle the problem of shared state by minimizing state, trying to get rid of as much of it as possible. The other prescription people came up with said that our code should be object-oriented and imperative, and the strategy here is that we simply segregate our state. We take the state that makes up our program, and instead of sharing it promiscuously, we try and divide and conquer the problem. We package it into these encapsulated units that we call objects, and objects contain other objects and so forth, and that's how we conquer the problem. And these two prescriptions are actually orthogonal to each other. We can do both the functional business to minimize the amount of state which our program deals with, and then whatever state is left over, we can then segregate into separate units of encapsulation. And in fact, I think this combination approach may actually be the ideal way to structure programs, at least in terms of high-level code, where we don't care so much about efficiency. As I'll explain, I think segregating state is actually a valid strategy up to a certain level of detail, a certain level of complexity. And so if we first minimize the amount of state which our code deals with, it then becomes a viable strategy to segregate the remaining state. You may have noticed in my definition of object-oriented programming that I said nothing about inheritance, and that is because inheritance is simply irrelevant. No one defends it anymore. Even people who advocate for object-oriented programming will very, very commonly these days tell you to be very, very careful in using inheritance, or maybe not to use it at all. And so it's not really pertinent to any argument about whether object-oriented programming is good or bad. For similar reasons, I didn't say anything about polymorphism in my definition, because polymorphism, really good or bad, isn't exclusive to object-oriented programming. You can...
If any of you don't know what polymorphism is, it's sort of the idea that a single object can have more than one set of properties. So you might have an object that's called person, and then you might have an object called man that extends the person object. And when I say object, I'm referring to classes in most instances. So if the person object is able to walk and speak, and then, or maybe a better idea would be to use, like, we have animal and then we have dog. So animal might have a method that says eat, but you can extend the animal class and create a dog class out of it. And now this new dog class is going to be able to, bark and fetch a tennis ball. But fundamentally, it's the same object. It's just extended. So polymorphism is the idea that you can sort of get multiple variations of any particular object through extending or, calling super, if you're referring to JavaScript specifically. Or I think the super keyword actually does the same thing in most languages. But again, I just want to reinforce, feel free to jump in or interrupt at any time if you have any questions or comments, please.
Procedural code that is...
I actually have a question, sorry.
Yeah, what's up?
Sorry, so this might be a total noob question, but I'm actually not really sure if I understand the concept of state that you mentioned before, about packaging the state and using as little of it as possible and separating it from the rest in object-oriented programming. Could you make an example?
Yeah. Okay. So when you think of state, we're really just talking about, we'll say, either an object or a set of variables that defines the current value of your application. So is this user logged in? True or false might be part of the state, or the user ID, or maybe you need to know their permissions. Is this an administrator, or is this a lower level end user? These are all stateful objects that your application is going to need to be able to work properly. So the biggest concern when you're working with state is that if you modify the state over here in, we'll say, class A, it lets you modify some global state. You might have class B, C, and E that all rely on that same state, and now suddenly if you change the value with class A, class B, C, and E all break because you don't have contingencies to handle the state. That's not necessarily a great example, but it's one of the reasons why you want to try to streamline your state. So if you're using React and you're using something like Redux, it follows a very strict pattern where you can't just jump in and say, okay, I want to change the value of user is logged in from false to true. You actually need to say, I want to update this value, and this is what I want the new value to become. And then you sort of send your data through a pipeline where it follows a set of rules to update the state in a very specific and predictable way. That's what's referred to as the flux pattern. And it just ensures that anytime you want to mutate your state, you're going through a pipeline with a specific set of rules and reducers to do it. The idea that you shouldn't be able to just modify state whenever and however you feel like it, while I understand why you don't want to do that necessarily if you have a big code base with a bunch of people working on it, imagine that this one stateful object is really important for how your component works, and everyone's using it, and someone suddenly decides that they want to change how it works. It's going to break everything. I think that it's good to abstract state, but I don't think that you necessarily always want to have it as like some global object that anything can have access to. So when I'm writing my applications, let's say I'm doing something on the front end with React or any other JavaScript framework. I'm going to try to tie my state to each individual component. So if I have a table that displays a list of users, within that component, I'm going to have my local state for that particular object. But again, it's very subjective. Everyone likes to do it a little bit differently, but all he's referring to when he says state is he's talking about variables that change and affect the way that your program works. Does that clear it up or not really?
Yeah, that definitely helps me better to understand the concept. Thanks for the explanation.
Yeah, of course.
Morphic, and in fact, even more polymorphic than is typically available in most object-oriented languages. So it's really not part of the discussion as far as I'm concerned.
Sorry to interrupt again, guys, but I should probably tell you this is a disclaimer. Although I'm like really passionate about programming and it's something that I love doing and I work as a developer, I'm also not an absolute expert. So I'm going to try to stay in my lane here. I'll try not to veer out of it if I can help it. But there are other experienced people on the server. So if I say anything stupid, someone please correct me if you know better.
When I complain about object-oriented programming, I'm really complaining about one idea: encapsulation. Encapsulation does not work, or as I should qualify this, encapsulation does not work at a fine-grained level, which is the core of what object-oriented ideology prescribes, that we need to take the state of our programs and divide and conquer that problem by chopping it up into tiny little pieces. That is the nature of object-oriented code, and it doesn't work. It leads to madness. Before delving into why object-oriented programming doesn't work, it is important to address this mystery of, well, if object-oriented programming isn't so great, why does it now dominate the industry, and why has it done so for almost the last 20 years? I've heard it sometimes suggested that, well, this was an imposition of management. Management wants interchangeable developers so that it can have a cookie-cutter assembly line development process. Hence, business types were really enthusiastic about object-oriented programming promises about code reusability and compartmentalization. It's a theory that sounds plausible to me, but the main sticking point is that object-oriented programming doesn't actually deliver these promises. You'd think people would have noticed sometime in the last 20 years, yet they seem not to have noticed. I'm also skeptical of the idea that management actually really inserts themselves in these technical decisions that often. I suppose once, say, object-oriented programming was well established and that became the pervasive norm, then yeah, sure, management would push towards doing what everyone else is doing so that they can draw from the larger talent pool. But otherwise, aside from pushing engineers to just go along with the legacy system and not rebuild everything, I just don't think that many business managers really care that much about technical decisions. I'm much more inclined to think that object-oriented programming is something that programmers did to themselves, and the question is then, well, why? I think a big part of the answer simply comes down to Java. When it was first introduced in the mid-90s, Java seemed like a welcome reprieve to many programmers. Compared to the alternatives, Java seemed really simple. For example, on the PC, this is what application development looked like. You had to use the Win32 API in C, and not only did programmers have to concern themselves with memory management as you do in C, but on top of that, Win32 just doesn't feel like the C that you would learn from books. It's not what you would learn from K&R. It's not what you would learn in school. It's all this excess macro-heavy stuff on top that is really mystifying. Even the tools you would use to write C programs on a Windows platform, the Visual Studio tools, wouldn't be the same as what you would learn in university probably, where you probably had a Unix system and that's what you learned. So it was already this platform with a quite high barrier to entry, but then also in this period it was undergoing this ugly transition from Win16 to Win32, and so you can begin to see why programmers were desperately looking for some way out. The only real alternative at the time in PC programming was Visual Basic, but that was another effective Microsoft platform you're locking yourself into, and I suppose otherwise you might use Pascal or Delphi, but that platform had its own issues. And so it shouldn't be too surprising that when Sun Microsystems came along and said, here's this free thing that everyone can use across all platforms, that got people's attention. And Java had other things going for it. It certainly seemed more accessible, just in terms of its naming conventions. For example, you look at the Java APIs and you see things like file input stream, which is not cryptic at all. Yes, there are definitely issues in how abstracted many of the APIs are, and having to derive base classes to use the APIs and all that nonsense. But on first glance, on surface inspection, it certainly seems like a friendlier system. It's not like Unix, where you have stuff like IOCTL, which is you're supposed to know is input-output control, and other really horrible abbreviations. And then Win32 had the same thing. LPCTSTR stands for long pointer to a const tchar string. So even if you know what a tchar is and a long pointer is, you're stuck in this world where everything is cryptically abbreviated, and it's just this goddamn puzzle that you have to figure out at every step. Java came in and said, no, we don't necessarily have to program that way. We can write real programs that don't have to be horribly cryptic in that way. And then Java took things too far in the other direction, but that's, again, we'll get to that. Java also smartly had the C-like syntax, the curly brace syntax, so superficially at least it seemed familiar to programmers from C and C++, and it seemed like real programming. It has curly braces after all. And then the whole compilation to VM bytecode business was, again, very alluring to programmers trying to escape their platform headaches. And then Java also offered some very basic niceties like proper namespaces without header files. For Christ's sake, we still have to deal with header files to do our real programming in C and C++ at least 20 years after we should have ditched them. If for this one thing alone, I think it's worth giving Java some credit. It mainstreamed programming without header files. And then, of course, also very alluring, garbage collection. I know some hardcore low-level programmers out there will insist that garbage collection is never necessary, it's never a good idea. But whether or not that's the case, it's really hard to argue with the appeal. It shouldn't be surprising that the vast armies of people doing business CRUD applications wanted to stop thinking about memory management. Java also mainstreamed exceptions as the primary way to handle errors, and whatever problems this may have in practice, I think it definitely seems appealing. Because the alternative is ugly. The alternative is what we do in C and C++ of having to have an inbound error return value, or saving to a global and checking the global after every time you do a call. It's not pretty. Golang with multiple return in that style probably is the better way to go. But that's not the solution Java came up with, and so it normalized this other thing that seemed better at the time. I think some people also came to like the subject-verb-object nature of method calls over straight function calls. Because, well, this is just what we do in English. It's subject first, then verb, then object. I myself don't find it all that appealing. I prefer consistency, and I think the distinction between subject and object in many, many cases gets very, very murky, which is one of the problems with object-oriented programming, as we'll get to. But this style of syntax in Java led to this convenience people, I think, since then have become addicted to, which is in their IDEs, it offers them, for this data type, what are my options? What can I do with this thing? It seems to enable a style of programming where you can just sort of browse. You don't have to hold all of the options in your head. You just have a vague notion of, wait, I'm going to take that thing and transform it into this other thing. I don't remember exactly what the method's called. I'll just grope my way there using auto-completion in my IDE. Again, there's really actually no reason you couldn't have the same style of convenience in a purely procedural language. You would just have an auto-completion for, given this first argument, what functions take this type as its first argument, and it'd be effectively the same thing, really. But because of quirks of history and syntax design, this particular editing convenience has been implemented for languages like Java, but generally not straight procedural languages. And I think method auto-completion may actually largely explain why people sometimes claim that object-oriented APIs feel easier to use. It's because you can largely auto-complete your way through most of the usage. Another thing Java seemed to have going for it is that back in the mid-90s, this was the heyday of GUI programming, and it seemed really logical to map components as we see them in a GUI window and classes in an object-oriented program. That seemed like a very natural correspondence. This was the most tangible version of the real-world modeling which object-oriented promised. At the time, it seemed like a very plausible story, and on top of that, you have the virtue of Java being supposedly cross-platform with the Java Swing API, so you can write GUIs that will run on any system. They'll look horribly ugly, but at least, hey, they run on everything. You could do so-called RAD, rapid application development of GUI applications like you do in Visual Basic, except in Java, you're not locked into Microsoft's platform.
So this, I think, is a really good example of when object-oriented programming really makes sense. So you might have a single class right here that's specifically responsible for authentication, and you might call the class authenticate or login panel, maybe. And then within that login panel, then you might have methods for login, cancel, or validate user credentials. And for the same reason, because I got my start with C# and WinForms, and it looks just like this, the user interface creation. But for the exact same reason, this is why I think that object-oriented programming is actually really great if you're doing game development, because I think it really makes sense to have an object or a class specifically for every item when you're doing game development. If you have a user, like a main character, you might want to have a class for that main character that dictates what happens when the hitbox hits a wall or when an enemy projectile hits the user. I think it's just a really good way to group your data. But also, when you're doing this type of user interface development, I'm not sure what's it called? Kinter? I don't know how to pronounce it. The Python GUI platform, or if you're using WinForms or any type of Windows MVC or Windows WPF application, it probably makes a lot more sense to use an object-oriented style when you're building applications with some sort of GUI builder, or even if you're not using a GUI builder, if you just have some sort of visual aspect to your application where maybe you're doing desktop development and HTML and CSS isn't necessarily the best solution for you. So I'm not going to hate on OOP too bad, because I do think this actually is a great application for OOP personally.
So the funny thing to me about Java is that I think in an alternate history, it could have had virtually all the same success, if not even more perhaps, if it weren't object-oriented at all. It could have just been a straight procedural language and would have had still a big long list of attractive selling points. We could have had all the same portability, the same garbage collection, the same exception handling, and so forth down the line without any of the object-orientedness. Or at the very least, without forcing everything into the mold of classes. You could have it of a language like Python, say, where there are classes, but also just straight procedural code if you want, and they can live side by side just fine. So there still is this question. Java aside, there seems to be some appeal to object-oriented programming in itself, and what is that? Well, I think very simply, if you go back to the 60s and 70s, as people were grappling with the problems of software systems getting larger and larger, people tried to identify units of code abstraction that were larger than individual functions and data types. It's natural to want to describe any complex system in terms of large-scale components. If you talk about human anatomy, you don't explain it first in terms of microbiology. That would be nuts. We first talk about very major organs like the brain and the heart and the kidneys and so forth. As software gets larger and larger, it felt like these units of code we were building out of, the base materials, these data structures and functions, they became smaller and smaller relative to the whole. Sadly, though, the one general answer people could come up with of what is a unit of code abstraction bigger than a function and bigger than a data type is just simply a combination of the two, and hence objects were born. We took our functions and our data types and we associated them together into these larger units. We want to think in terms of paragraphs rather than individual sentences, and object-oriented programming seemed to have an answer for how we could do that. It's also very natural that as we build larger and larger systems and complex things, as much as possible, we want simple rote rules to guide us. Object-oriented programming seemed to present a unit of abstraction and a set of guidelines whereby we could incrementally accrete larger and larger systems. This line of thinking is what led us to patterns, and then the so-called solid principles and dependency injection and test-driven development, and all this stuff which has subsequently been piled on by many people who insist that this is now the one true way to do object-oriented programming. But to me, all these best practices represent band-aids. They are compensation for the fact that the original vision of object-oriented programming has never panned out, and every few years there's a new ideology in town about how we actually do object-oriented programming for reals this time. It's very easy to miss this dynamic. I know I did for several years, because I think within all of these addendums to object-oriented programming, there's lots of mystical speech dancing around genuine insights, but it's not quite cohesive. Object-oriented programming feels like this circle which we've been trying to square for over a generation now. Finally, let's talk about what's really wrong with object-oriented programming, specifically encapsulation, which is the linchpin of the whole thing. So consider, what is an object? An object is this bundle of encapsulated state, and we don't interact with the state of that object directly. All interactions with that state from the outside world come in through messages to the object. The object has a defined set of messages which it will receive, called its public interface, and so we have private information hidden behind a public interface. When an object receives a message, it may in turn send messages to other objects, and so we can conceive of an object-oriented program being this graph of objects all communicating with each other by sending messages.
When he says object here, think classes if you're working with any modern language. C#, Java, JavaScript, TypeScript, Golang. Actually not Golang, but that's what he's saying when he says objects. He's talking about classes in these examples.
Many people today forget, though, that the original conception of a message is not exactly synonymous with just a method call. Yes, in practice it means calling methods, but a message, strictly speaking, sends only copies of state. It doesn't send references. A message sends and returns information about state, not state itself. And, well, wait a minute, objects themselves are state, and this has some interesting consequences. It means that, strictly speaking, messages cannot pass around object references. I've never seen a Java or C# codebase that ever follows this rule. Perhaps some Smalltalk programs have, but in general, this rule is not observed at all, and probably for good reason, as we'll discuss. But anyway, if we take the rule seriously, it means then for an object to send a message to another object, the first object must hold a private reference to that other object, because otherwise, how is it going to talk to it? To talk to an object, you have to have a reference to it. And where is an object going to get a reference to another object if it can't get object references from messages? The references which an object needs have to all be there at the object's inception. They have to be there for the whole lifetime of the object. And there's an even deeper consequence, which is that if an object is sending messages to another, that other object is part of the first object's private state. And by the principle of encapsulation, an object should be responsible for all the objects which it sends messages to. And this should be obvious if you consider that messages indirectly read and modify state. When B sends a message to A here, it's messing with the state of A. Indirectly, sure, but it's still messing with its state. And so what happens when other objects come along and send messages to that same object? What's happening here? We have shared state. It's hardly any different than if you had a single global variable being shared by, say, 10.
So, Calvi, when you say, what's he talking about when he says messages send only copies of objects? So what he's saying, let me think if I can articulate this in an easy to understand way. So, for example, this object right here, if it let's go back to our to-do list example. I'm going to keep using the to-do list example because I think it's the easiest one to work with. If A right here is the object that's in charge of managing the tasks in your to-do list, and object B is some sort of user input, an object that controls user input. So the user says they want to add a new object. What it's going to do, object B here, is going to send a message to A saying, I want you to run the add new task method. So when it sends that object, what it should be doing is it should be saying, okay, so here's a list of the to-dos, and we have 4 of them. We want to add a 5th item. And in order to tell this object right here that it needs to make the ID for the 5th item number 5, it might send over the array of current tasks and say that the array length is what we want the new ID of the object to be. Now, object A has that array of objects because B just sent it to A. So in that process, now A has the ability to mutate that object. So if A now wants to make a change to task number 1 or task number 2, instead of just adding task number 5, A has the ability to do that. However, if instead of sending the tasks from B to A, you should be sending a copy of that array so that if object A decides that it wants to start messing with the array for some reason, it doesn't change the previous tasks that you didn't want to manage. So that's what he's saying when he's talking about sending copies of data instead of sending the actual state itself. So does that make sense, Calvi?
Yeah, I thought he was talking about like pass by reference, pass by value.
Yeah, so again, even if you send a reference, so if we're working with like C++ and pointers, if you send a reference with a pointer, then that object can still be mutated. So I think that's what he's referring to by sending a copy of it instead of sending the object itself or sending a reference or a pointer. You don't want to send state that can then be mutated by a different class.
I get that. In some languages, you could specify whether or not you want to pass in a reference or pass by value. But in Java, I think the references, the objects are passed by reference.
I personally wouldn't know that. I've never really worked with Java. Are you talking about by using like private or public interfaces?
Like when you create a method and you pass in a parameter and that parameter is an object, anything that you change within the method is also changed in the object, not the copy of the object, but the object itself.
Okay, so you're saying that like in Java, it's an option to send one or the other, that you can do
No,
both.
in C++, it's an option to send one or the other. In Java, it's not.
Okay, that's interesting.
For primitive data types, it's sent using copies, but for objects, for references, it's you mutate right on the object itself, not a copy of the object.
Okay. All right, that's interesting. Okay.
Functions. If you have an object receiving messages from 10 other objects, those objects are all effectively tied together because they're implicitly sharing this state. Sure, the interactions with that state are indirect through public methods, but those methods are providing very trivial kinds of coordination of the state. You can impose rules through the accessor methods like saying, oh, if you access this field, it's a number, well, you can only increment that number. You can't mutate it in any other way. Fine, but this is a very trivial kind of protection. The hard problems of shared state are much, much deeper. Where in the system of 10 objects all sharing this state is the real coordination? And the answer is there isn't any. As soon as you have objects being shared, encapsulation just flies out the window. So if we're taking encapsulation seriously, the only real way to structure a program, to structure our objects as a graph, is not as a freeform graph, but as a strict hierarchy. At the top of our hierarchy, we have an object representing effectively the whole program. It's our God object, and that has its direct children, which represent the subcomponents, and those children in turn have their own subcomponents, and so on down the line. And each object in the hierarchy is responsible for its direct children. And the messages being passed strictly only ever go from parent to their direct child. The God object here, for example, is not supposed to reach down to its grandchild. It has to do all of its interactions with this grandchild indirectly through the grandchild's parent.
So if you're familiar with React, this is exactly what the context API is supposed to fix. because I'm sure you've all been in a situation before where you want to mutate some state, and in order to do that, you need to send that state down from component to component to component to component, and then you also need to send down your set state variable or your set state function from component to component to component to component, so that when you update it, it passes it up the chain. Like there's a term for it. I think prop drilling. So you have those props that are going through a number of different components. It makes your code really difficult to debug. So the context API makes it so regardless of where your state is located, you create sort of a context object, and then you can invoke that context object wherever you want, and you can mutate the state that way instead of having to pass it down through a series of props and creating functions to mutate those props. So that's a good modern example of what he's talking about here.
Otherwise, who really is responsible for that object? Who's managing its state? It's supposed to be the direct parent. And so what happens when we have some sort of cross-cutting concern, like down in the hierarchy, it turns out, oh wait, there's some business that object has with another object in a totally different branch of the hierarchy. How do they talk to each other? Well, not directly. Everything has to go through their common ancestor. For A to send a message to B here, it can't actually directly invoke any kind of method. It has to mutate its own state in some way, and then information about that state, that new intention of the object, gets returned from a message sent from A's parent. A's parent in turn, same thing has to happen, so it gets back up to the common ancestor, and then only finally when we get to the common ancestor can that intent be realized as a series of message calls, but not directly down to B. It has to be bucket brigaded down through the hierarchy. That is how you handle cross-cutting concerns in a strict encapsulated hierarchy. Obviously, no one writes programs this way, or at least no one writes whole programs this way. And for good reason. It's an absurd way to have to write your code. Now,
and something else about this, it might be really good to plan your applications to work this way. From my experience, the reason that I don't do it so much at work is because what I'm tasked with doing changes all the time. The clients might change what they want, or maybe my manager doesn't like the way something works and they ask me to change it. The fact of the matter is, you just can't plan your application from the top down, because software development never works that way. You're always going to run into unexpected issues, or the requirements are going to change. So I think that's why this really becomes a problem. If you knew every last bit of functionality that your application needed, it would be pretty easy to plan and then build your application to work in a strictly hierarchical type of way, like that graph he just showed. But in practice, it never plays out that way. Never.
you might argue that people do follow these principles in practice, they just do so inconsistently. And perhaps there is some value in a code base where you apply these principles inconsistently. Perhaps half-assed encapsulation actually gets us something. So imagine we have some sort of free-form graph of objects making up a program, and we decide, oh, well, there's this subsystem of objects that together should be their own self-contained encapsulated hierarchy of objects, and so we're going to refactor our code. Well, very often what that means is not only do we have to do a lot of complicated rethinking of the structure of the relationships here, of what calls what on the other objects, we very typically have to introduce more objects. Like, say here, to represent this whole new subsystem, we probably have to introduce some new sub-god object, some ruler of this subsystem. Now, all interactions with the subsystem have to be reconceptualized as going through this minor deity. So, say we successfully do this refactoring, and now, while our code doesn't follow the principles of encapsulation perfectly, it's doing so in a half-consistent way, and maybe there's some benefit there. Well, I think what tends to happen is subsequently we decide, oh wait, we need some new interaction between elements of this encapsulated subsystem, and instead of having to do the hard work of figuring out how exactly it all gets coordinated from the root of that subsystem, the temptation is to just handle the business directly. But if we want to do the proper thing, we have two options. Maybe it turns out that that stuff external to the subsystem actually just needs to get integrated into that subsystem, and so it comes under the purview of the subsystem's root. But otherwise, we now have two subsystems that need to coordinate. And who's going to do the coordination? Well, now we need a new subsystem God object responsible for the collective business of these two subsystems. And now all interactions of these two subsystems have to go through this root object, but also all interactions with the outside world and these two subsystems have to go through this new root object. So as you can see, chances are really good that what you would actually do is say fuck it and just do this. You would just reach in and have the objects directly interact with each other, whether they should properly do so or not. And now, where's the encapsulation? What's the point? Whether you follow the rules strictly or loosely, you're in a bad place. If you follow the rules strictly, most things you do end up being very unobviously structured and very indirect, and the number of defined entities in your code base proliferates with no end in sight. The nature of these entities tends to be very abstract and nebulous, but alternatively, if you follow the rules loosely, what are you even getting? Why are you bothering? What is the point? When I look at your object-oriented code base, what I'm going to encounter is either this over-engineered giant tower of abstractions, or I'm going to be looking at this inconsistently architected pile of objects that are all probably tangled together like Christmas lights. You'll have all these objects giving you a
I don't know
fuzzy
about
feeling
this.
What don't you think is accurate?
The entanglement of the hierarchies. I mean, I think that could happen with, a bad coder, but for the most part, I think OOP simplifies the hierarchy rather than complicated.
But think about this, because I don't actually disagree with you at all there. But if you're working for a company and you build out exactly what they ask you to build, but then the specifications change, and it's something where, okay, I can just sort of punch a hole in this wall and mutate this state from this object, or I could redo my entire dependency graph and rebuild all of this functionality, and you're on some sort of deadline where you just need to get this thing working. And then this is a code base that's active for, months or years.
What do you mean?
Yeah.
When you say something gets changed?
Yeah. Okay. So
specifically.
Okay, I'll give you an example of something I just recently went through. So we were building a speaker portal, and what I mean by that is these pharmaceutical companies have these speaking engagements where they invite doctors in to give speeches about new medications. When we originally built this, we had two types of users. We had the speakers, and then we had the organizers, like the people who set up the events. So they both see different things when they log into the application. They have different permissions. Then, all of a sudden, after I was building this app for several months, the client decided, you know what, we actually need a third type of user. We need, they're called thought leaders. So we need someone who is familiar with the industry but not related to the event to come in and see completely different information. So now it's a matter of, okay, well, do I just sort of like knock everything down and start over from the ground up? Or do I just sort of like break the rules of the organization and build in some patches that allow for different data to be shown or modified without strictly changing?
Polymorphism will help you do that. Meaning that depending on what the object is, it will call that specific method.
Yeah.
So
okay, I see.
And polymorphism is a principle of OOP.
Right. Yeah.
I think it's like having cars. It's like people want to drive Ford, people want to drive Toyota. It doesn't mean OOP is bad. It's just a different way of doing things, and I don't think it's necessarily bad or good. I can see the bad and good in OOP as well as functional programming. Mm-hmm. They're just different paradigms, really. And I think when you recognize the differences, the pros and cons of them, and when you face a task at work or coding-wise, you get better at choosing which paradigm you want to follow and stuff like that.
Yeah, and again, I don't think object-oriented programming is like some horrible paradigm that people shouldn't use. I think that, like, in a perfect world, yeah, that's all very true. But I think at least from my experience, what I tend to notice is that when you have multiple developers working on the same code base, it doesn't matter how organized you are with your code. Other people are going to build things that interact with your code in ways that you didn't intend for it to happen in the first place. And so I think a lot of the times we're just trying to figure out, well, what's a pragmatic solution to get this implemented and make the client happy without having to add another 300 hours to our development cycle. So I think that like he's stating these in some very inflammatory ways, but the way I sort of hear it, I guess, is that just do what's pragmatic, do what's easy, do what makes sense and what's easy to follow. And so like if you're working at Microsoft and you're part of like the operating system team, I'm sure that it's probably an object-oriented code base because everyone needs to have very specific roles. They're all working on very specific functionalities, and you need to make sure that you stay in your lane. But when you're working for like a small company or a startup, and it's a little bit more of a free-for-all, a little bit less organized, I think it's just almost impossible to make sure that people are following the dependency graphs in a perfect way that that like keeps it completely organized. So like I do believe that everything you're saying is completely true. I'm just saying, I guess, like from my experience, it very rarely ever feels that way when you're working with a team of people.
Yeah. Okay.
Okay. I'm gonna pull up that article.
Yeah,
you just sent me a little bit.
JavaScript has both functional and OOP, and
Yeah.
it's just
Well, I think most programming languages, you can use any paradigm that you want to. I can't really think. So I was talking earlier about.
nah, Java is definitely
OOP, yeah.
OOP strictly.
Yeah, that's true. I'd actually be interested. I wonder if you could write functional code in Java, because ultimately the only.
No, you can't.
Even
It
if
starts off as an object.
right, but you know how with OOP you have those four paradigms. There's encapsulation, abstraction, polymorphism, and inheritance. Once you're inside of that main function or that main method, I guess you would say, you don't necessarily have to follow those paradigms. As long as the application starts, you can write your code however you want in there. Didn't Java actually just add Lambda functions recently? And isn't that specifically?
Yeah.
Okay. Yeah. So I mean, I guess you can write functional code in Java.
It's more OOP than anything else. Like the class, the name of the file has to be like the name of the class has to be the name of the program. Like the what is that called?
The name.
Like in your source file, you have different classes, right?
Mm-hmm.
And each of them has to adhere to the name of the file, like account.java has to have that name. Like the name of the class has to be the name of the file is what I'm trying to say. Yeah.
So it forces you to use encapsulation, basically. So I guess the question is, can you still write an imperative or a functional style of code if you're forced to encapsulate that code? I actually don't know the answer to that.
You can with static methods.
Right.
You can with static methods, but the whole point, like the first thing you do in Java is create a class. So that static method has to be in a class anyway. That main method has to be in a class anyway.
Okay, and I don't.
You get what I'm saying?
Yeah, I do understand what you're saying. I haven't personally used Java for more than like a single day, so I'm just curious. Do you ever see a Java code base where everything takes place inside of that main class? And I'm not saying like all of your code is in there, like thousands of lines, but can you create other files and then just sort of import code from other files without having to have each of them encapsulated into their own class? So if you have like accounts.java, can you just import that file and then reference it from your main entry point?
Yeah, of course. You would just create an object for account.
Okay. Yeah.
In the main method.
Have you used the Lambda functions at all?
Yeah. That's basically when you call a function and it's a function in itself, right? Like,
Yeah,
how do I say it?
like those arrow function, that arrow function syntax where you can have
Like
anonymous
the arrow
functions.
function, right?
Yeah,
Right.
and then you can pass
That
functions.
executes right after you call, or is that closures?
Well,
Right, yeah, the lambda function.
yeah, if you would use a closure when you want to invoke a function immediately. So in the JavaScript ecosystem, you refer to that as an IFI, or an immediately invoked function expression. But I think the most important part about functional programming, or maybe not the most important part, but you're supposed to be able to pass objects as pass functions as parameters into other functions. So the functions are first class. I don't know if Java functions are first class, and I'm actually gonna look that up. I'm really interested to find out. Okay, in Java, methods are not first class objects. The closest we get is Java lambda expressions. So it looks like Java lambda expressions are first class functions, which again is probably just because functional programming.
First class functions meaning what exactly? I'm not familiar with that term.
Yeah, first class functions means that it's a primitive data type that can be passed in as an argument to other functions. So if you have a function called,
okay,
let's say you create a function and it's called add, and it takes two values, which is number 1 and number 2. You can call that add function, and then for one of those numbers, like number 1, you could reference another add function where you then add 1 and 2 together in there. So you're passing a function with its own properties as a property into another function.
Okay.
But it looks like in Java it has to be a lambda function to be able to do that. Okay, interesting.
Okay.
Encapsulation, but you're not going to have any real encapsulation of any significance. What people tend to create when they design object-oriented programs are overly architected buildings where the walls have been prematurely erected before we have really figured out what the needs of the floor plan are. And so what happens is down the line, turns out, oh wait, we need to get from this room over here to that room over there, but oh wait, we've erected barriers in between, so we end up busting a bunch of holes through all the walls, like the Kool-Aid guy.
And Kelvy, this is exactly what I was talking about how like the needs of the application are always changing. And this is the biggest problem I have with it. It's exactly what he's talking about right here, is that suddenly the client says, okay, we actually need this other view right here. The project is due on Friday. You know, are you going to re-architect the whole platform to make a minor change, or are you just going to punch a hole in a wall? And I think most of the time, the developers are just going to punch a hole in the wall to get this thing done. And now suddenly the code base doesn't follow any rules anymore.
Right. I get what they're saying. They're saying that, like, if you wanted to extend a room or something like that, you know, the refactoring is an issue in OOP. But I think refactoring is somewhat trivial.
Well, it's not trivial. An issue. If you have a strict timeline, it might not be trivial because,
Like if you wanted to create a new room, right, you would just make an object for that, a class for that room. And then that's how you would make the changes.
I think.
But everything inherits from the building house, the house. So, you know what I'm saying? Like,
yeah, but using this analogy, I guess let's say that this room right here is a bathroom, and this right here is your bedroom, and you realize suddenly, oh, there's actually no way to get into the bathroom without leaving the house and coming in through this window. So necessarily, what you have to do if you're refactoring it, anything you do is going to interfere with these objects in the middle, because you're going to have to sort of like move them out of the way or change how you interact with them in order to sort of build a hallway there. You can't just like build a hallway through these rooms without affecting all of the rooms in the middle in the process. So it's not that you can't refactor, but again, if you're on a timeline, it could potentially be really time consuming or difficult to do that without breaking other things in the process. I mean, again, I'm not hating on object-oriented programming. It might sound like it just because I'm personally aggravated with some stuff I've been refactoring. But do you understand like my frustration with that?
Yeah.
But
What I'm saying is, like, if you wanted to add a new room, or you would just create a new class and inherit from
the
the
object,
structure, the house, whatever.
Yeah.
And specify the room to your liking. So, but I get what you're saying when it comes to going backwards, I guess. And let's say the room that you created wasn't the right height and width, then you would have to refactor all those, right?
Yeah, absolutely. Or it might also mean that you're going to be passing data through objects where it doesn't belong. So to sort of build a hallway right here, now suddenly you're passing user credentials through some object that's specifically meant to fetch data from the database. And now you have data passing through this object that really doesn't belong there, but since you didn't have like the full picture of what you were building originally, that becomes the only way to do it in a clean way without completely re-architecting everything. So I guess just like the real world applications of this are, no matter how perfectly you want to build everything, it just feels to me like I never have enough time or energy or support to do it that way. But maybe if I was working for a larger company with more people and more standardized guidelines, I wouldn't be so frustrated by this personally. That just happens to be my experience working for a small pharmaceutical company. I'm glad you joined though. It's nice to like get some pushback and actually like talk through some of this stuff.
And the resulting pattern is really not organized at all, it's just Swiss cheese. We thought we were being disciplined, neatly modularizing all the state, but then the requirements changed, or we just didn't anticipate certain details of the implementation, and we end up with a mess. The lesson we should take from this is to be very careful about erecting barriers, about imposing structure. It's actually better to start out with a free-form absence of structure rather than impose a structure that will likely turn out to not really fit our problem. Bad structure that doesn't really fit our problem not only makes it harder to implement the code in the first place, it hinders change, and it confuses anyone who looks at our code because it's implying one thing, but then what's really going on is another. In the object-oriented world, we have to think about all these graphs. We have to think about an inheritance hierarchy. We have to think about a composition graph. We have to think about data flows between the object, and also we're thinking about a call graph. The liberating thing about procedural code is there's just the call graph. We also, of course, do have to think about how our data is structured and how our data gets transformed throughout the course of the program, but the beauty of procedural code is that we can think about that totally independent of any notion of responsibilities. When I'm looking at my data, I can think just about my data, and when I'm looking at my functions, I'm not thinking about all these self-imposed barriers. I'm not constantly trying to group and modularize everything into these small units of so-called single responsibilities. When I sit down to write object-oriented code, I always have to play this game. I have this mental list of the obvious data types which my code will deal with, and I have this separate mental list of all the imagined behaviors I want in my program, all the functionality I imagine it to have. And then what object-oriented ideology demands is that I take all my behaviors and I somehow associate each one with one of my data types. Inevitably, what this means in any non-trivial program is I'm actually going to have to introduce all sorts of additional data types just to be these containers for certain behaviors which otherwise don't naturally fit with any of my obvious data types, the data types I knew I actually wanted because they represent actual data I need. In fact, as programs get larger and larger in object-oriented code, it tends to be that these unobvious, unnatural data types tend to actually predominate. You end up with majority of so-called data types, which really aren't there because they're representing data. They exist simply as attacks to conform to this ideology about code modularization. Very quickly, we end up in what Steve Yegi called the kingdom of nouns, where every aspect of our program has to be reconceptualized as not just mere standalone verbs, functions. They have to be reconceptualized as nouns, things that represent a set of behaviors. And so what we get in our object-oriented code bases are all these service classes and manager classes and other what I call doer classes, these very nebulous and abstract entities. even when dealing with data types and behaviors that are relatively concrete, which have fairly visible connections to the functionality apparent to actual users of the program. Even here, the matchmaking game constantly presents us with these obnoxious philosophical dilemmas. In object-oriented analysis and design, we constantly have to ask ourselves stupid questions like, should a message send itself? Because maybe instead we should have some sender object which sends messages. Or wait a minute, maybe there should be a receiver object which receives messages, or a connection object which transmits messages. So very quickly, the real-world modeling which object-oriented programming promises becomes a fool's game, where there aren't any real good answers. In my experience, object-oriented analysis and design very quickly becomes analysis paralysis. If you take the ideology seriously, as I did, you're going to waste a lot of time hemming and hawing about to conceptualize these elements of your program. Object-oriented programming is generally sold to students on the basis of these trivial examples that neatly model real-world taxonomy, but what we get in practice from object-oriented analysis and design is a lot of very abstract excess structure with no obvious real-world analogs. Note here that programmers have their own peculiar definition of abstract. When programmers talk about abstraction, they're generally talking about simplified interface over complex inner workings. What's odd about this is that in more general usage, abstract has a connotation of being hard to understand. Something which is abstract has no resemblance to the things of common daily life. And it turns out that most things which programs do are abstract in this sense. And so it shouldn't be surprising that we have great difficulty conceptualizing the components of a typical program in terms of neatly self-contained modules, particularly modules which have any real-world analog. When we pollute our code with generic entities like managers and factories and services, we're not really making anything easier to understand. We're just putting a happy face on the underlying abstract business, and for every excess layer of abstraction, we're getting more abstractness. In attempting to neatly modularize and label every little fiddly bit that our program does, we're actually just making our program harder to understand. Something that happens all the time when I look at object-oriented code bases is that I'll try and find the parts in code that correspond to some user-visible functionality. But trying to find the functionality going by clues from the names of classes and the names of methods tends to be very misleading. Very typically, my expectation that functionality X would be in the class named X turns out to be wrong, because the abstract nature of what we typically do in programs generally necessitates that functionality is not going to be self-contained. It's not going to neatly fit.
That's a problem with implementation. Sorry to
cut
you off.
Yeah,
That's a problem with the coder.
Yep.
Naming the classes, not really con against abstraction itself.
Yeah, you're 100% right about that. And so
yeah.
I guess the where I find it to be frustrating is that like when I had taken over these code bases and now I'm tasked with working on them, and the guy before me or actually I don't even want to blame him because I don't think he was a bad developer, but I think it was one of those situations where, again, when something changes, when the client suddenly changes what they want, and now you have this class called like object marshaller or something. It's one of those weird names where a new person isn't going to know exactly what it does when they look at it, but now suddenly this object marshaller is also responsible for updating the database or verifying authentication, just because that's the only place it made sense to put that functionality. Then when you're the person debugging this code and you're looking for a name that doesn't exist because it's nested inside of a class with an unrelated name, it's, is that the developer's fault, or is that, the fault of the client for changing what they needed halfway through the project? It's just never really clean enough. But so I can't, again, I just have to say this. I don't think object-oriented programming is actually bad. I just think that living in an imperfect world, it becomes really hard to know that it's reliable. But yeah, you're right. It's definitely an implementation problem. It's not a paradigm problem for sure. Just out of curiosity, Calvi, have you built any apps for school or in your free time? Where are you with your education or your experience right now?
I mentioned this last time. I just graduated with a computer science degree, and right now I'm looking for a job and just practicing lead code.
Okay. Did you have any big projects in school where you actually built?
Yeah, definitely.
Okay.
Yeah.
And did you write all of your code in an object-oriented style?
No, no. We learned Java and C++, so there was a mixture of OOP and functional.
So how did you plan your applications out before you built them? Did you use some sort of modeling, like I forget what it's called, like the data modeling where you have the boxes
Like
and
UML?
UML, yeah.
Um, I like what was my approach to
Yeah,
the
so
project?
if you're about to build a project and it has maybe like a user interface, it has a server and it has a database, and you need to map out how all the functionality is going to work before you start actually building the app, do you tend to write pseudocode or do you use UML or do you just actually like physically map it out on a piece of paper and write down your ideas and move stuff around as you need to? Like how do you go about planning applications?
Right. So I would I would do more modeling, honestly. Um, More like what's the class, like what's the noun, like what's the object that I need in order to do something or change something. You know what I mean? So the way I like right now, my current program is bank account. So I have just a class called account, and I have something called another class called loan account and savings account. And this loan account and the savings account inherits from the account Java. And then I create another class where I put the main method of the Java program. And that class is the one that executes and uses the other classes in the main method.
Okay, and that actually sounds
Does that
like
answer your question?
it does. That sounds like a perfect implementation for OOP because it models something in the real world, right? So like if you're modeling a bank account or the way a bank works, you're sort of recreating a bank in a programmatic sense. So I think that's actually like a really good implementation for object-oriented programming. I'd
Yeah.
be really interested.
Yeah.
I think it would be really fun to do some sort of like, um, I don't know, with either the Discord server or just a few people who are interested. It could be really fun to do some sort of like real world project at some point. I'd be really interested to see what everyone's programming styles are like. There's this guy that we hired a few months ago, and he's really smart, or really experienced, I should say. He's been programming for a long time. And so if I get stuck on something, I really can't figure out how to do it. So like if I'm working with an old API and it's using some weird authentication protocol instead of OAuth 2 that I'm more familiar with, I'll go to him because he's been doing this for 20 years and he knows, okay, yeah, 15 years ago, this is how we used to do it, and he'll walk me through the process. But then when I'm maintaining code that he wrote, I tend to get really frustrated because I'm like, I never learned to do it this way. And that's not me saying that like his code is bad. It's just me saying that like I learned more recently, and so I find his like older style of code to be really difficult to navigate sometimes. And so I think, it's just we live in a very imperfect world where like programmers all have their own styles, they all want to do things their own ways, and if you don't have some sort of style guide that you're enforced that's enforced at your company and that you're required to follow, it gets so extremely frustrating sometimes.
Yeah, that's one of the pros of OOP, in my opinion, is that it gives you a structure to work with.
Is Java your primary language?
And some people like that structure, but some people don't.
Yeah. Is Java the language that you work with most often?
It's what I do for lead code, and I would say Java and JavaScript, React, yeah, Node.
So when you're using React, because React is a very functional style framework, where all of your
Right.
does that feel weird for you to write, or uncomfortable or unintuitive or anything?
No, not at all. I first learned React using class components, actually.
Oh,
then-
interesting.
And then I shifted towards functional components. And I actually do enjoy the functional components. So it's not like awkward or weird for me to shift, I guess.
Okay.
But it might be for other people.
Do you have any projects that are like up on GitHub? Not today, because I don't think I'm gonna have time today. But I'd really like to look at some of your code at some point, if you're okay with that.
Yeah, I DM'd you my resume and stuff, and it has links to those projects.
Okay. Yeah, I'll definitely check that out. That Amazon clone that I looked at, was that yours or someone else's? I really can't remember.
It was mine, yeah.
Okay. I don't
Yeah.
think I looked at the code for it though. I just looked at the live website. Is that
Right.
is that code on GitHub?
Right. It's on GitHub, yeah.
Okay, I'll have to check that out soon. I'm really interested to see what it looks
That
like.
project was actually how I started with React, and I started using class components, and then I made a similar one using functional components just to get my feet wet and stuff like that.
Okay.
You know what I'm saying? So
Yeah.
I made two of the same project, basically.
Okay, I got you there. All right, and so Nathan Exclusive just got a message saying, my opinion on OOP. Sometimes it's essential, such as state management in a React app. Otherwise, if I don't need to use it, I absolutely won't. What I'm confused about with that, Nathan, is essential, such as state management in a React app. I would say that state management in a React app is actually completely functional, especially if you're using Redux.
Yeah, it's more functional in my opinion.
Yeah, I don't think there's anything OOP about it, unless maybe you build your own state management library, and the way that you use or change state is to invoke a class that specifically manages your state. So I'm not entirely sure what you mean by that, but yeah, I'd be happy to talk with you more about that if you want to at some point.
Yeah, I'm here. Sorry, I was trying to find the stream. But so when you create like a React app, and this is just completely off of like, I understand that the motion has shifted more towards functional components, but like that wasn't always the case way back when. When you're doing a React app and you create classes, right? In order to do that state management, you would have to have like let's say you're creating like a game, right? Like chess. So you have like the board, and then underneath you have like tiles of the board, and then it just kind of it delegates from there, right? Is kind of like inheritance. And because of how React operates, it operates from a data flows down kind of method. So in order to have like the state management, like you move like a pawn up to one square, you have to say, all right, you'll have to like declare it up on the board saying like, hey, I want to manage the state of these squares that's like my child, right? And then from there, that's when you can say inside the square itself, update this square, and then it'll pass it up onto the board, if that makes sense.
Are you referring to React with class-based components, where you would have like you would create these higher order components and then pass components into new components as arguments, and then sort of drill your props down through there? Are you talking
exactly.
Okay, so you're saying state management if you're not using a state management library like StateX or
Redux.
Redux. Okay.
Yeah, yeah, exactly.
Okay, and if you're building a React app, just out of curiosity, how would you choose to do your state management today in 2022?
Oh, absolutely, Redux. Redux, like, but I do not recommend anybody just jumping straight into Redux. I feel like if you're learning React, you should go in and learn like use effect, use refs, and all of that good stuff before you
Yeah,
hop
100%.
into Redux, just to
Yeah.
understand like the basis of everything, how it all works.
I personally hate Redux. I absolutely hate Redux.
Really?
I do. Well, I think it's because I work with Vue a lot, and I really like Vue. And Vue has a state management library called Vuex, which is based off of that same Flux pattern, but in a way that's like 1,000 times easier. So I know that Redux Toolkit has gotten more popular, but anytime I had built an application using Redux, what I end up doing is I end up adding Immer and what's the other one? Immer and Thunk. It's like two more libraries that you need to add to Redux just to get it to handle asynchronous data and to be able to mutate data without having. Man, I don't remember. It's been a while since I've actually had to mess with this. So I imagine that if you're using Redux Toolkit, it's probably easier. But with Vuex, it's so easy. You just say, this is the state that I want to edit, and this is what I want to change it to. And then actually creating the boilerplate for that is so easy. So I think that by comparison, Vuex is so easy that it's made me personally hate Redux because of how much boilerplate and setup it has.
You know, in my experience, Vue is just like Vue is pretty awesome. You know, it just takes everything about React and it like kind of simplifies it. You know, I do agree though. Vue is pretty awesome. I've been like swapping back and forth between React and Vue.
Yeah, they're both a lot of fun.
I didn't think React could get simpler, but now I have to look at Vue.
Yeah.
You think React?
I
is
thought
simple?
React
Oh
was
my
pretty
God.
simple, yeah.
Yeah, that's crazy. I think to this day I still think is pretty complicated.
Yeah, I think React's pretty complicated too. I think it's a lot of fun. I probably shared with you guys before that when I was trying to learn a JavaScript framework, a front end framework. I gave up on React like 3 times, and then I eventually learned Vue. And then once I learned Vue, then React became really easy for me to pick up. I think it was just so many concepts because you've got to learn you need to learn how to build in that sort of functional style. You need to learn JSX. You need to learn React hooks. And then especially if you're working with an older code base or some weird packages. So if you're working with like D3.js or one of those like chart.js, one of those libraries, it might not work with function components. You might have to actually use a class component to be able to use that framework within it. So, I mean, React is pretty complicated, and I give anyone who learns it credit because it really isn't all that easy. If you pick up Svelte, you could pick up Svelte in a single day or 2 days. You could pick up Vue in about a week or even like a couple hours if you're really focused. But React is like, that inside of 2 months, you're still not going to know what half of the hooks do. You're still going to only have used like a small fraction of the functionality. But I think that's also what's awesome about React is that it works for so many different things. There's so many awesome abstractions for working with React.
Oh yeah, there's so much potential with React, and that's why I'm like trying to dive deep into it. But man, it's tough. It really is. Good on you, Calvin.
Real quick, Marvin, I see your message. I'm not going to go too deep into it right now. Just I don't want to like derail the conversation. But the quick short version.
Just say what you're doing, I guess.
What's that?
Just say what you're doing, like.
Yeah,
Never mind.
I'm working as a developer in the biopharmaceutical industry right now, building applications for doctors and pharmaceutical companies. I've been doing this professionally for about a year. I spent the 2 years before that building out a startup. So again, building all my own software. And then for about 4 or 5 years before that, I owned a collection agency for about a decade before that, but from 2016 until 2019, I was sort of acting as like a data scientist within my agency, and then building software for my company with C# and .NET. So that's my quick background. Okay. Cool. All right. Any other questions or concerns? Should we resume the video? We only have about 15 minutes left here, not even. All right.
Neat module. And so the class which is called X will very superficially relate to X, but then all the real work is done elsewhere, scattered throughout the code. This makes me question, what is the value of having a class called X if it doesn't really contain all the business of X? What this class X really represents is actually misleading code structure, and how is that helpful? How is that conducive to understanding of your code base? The other reason I have this problem reading code bases and trying to track down where functionality actually lives is because object-oriented design tends to fracture functionality in our code. It tends to take what otherwise could be relatively self-contained code and split it up into many separate methods across many separate classes, typically often in many separate files, for God's sake. This fracturing is accepted because of an ideology about encapsulation and this notion of classes and methods properly having so-called single responsibilities. And there are certainly valid arguments for that idea. Certainly it is much easier to get a small short function correct than to get a large sprawling function correct. But the important question is that in splitting our code up into many little small methods and to many separate classes, are we actually decreasing the total complexity of our program or just displacing the complexity, just merely spreading it around? In either case, there's this attendant trade-off we're making where by splitting up larger units of code into many smaller ones, we're greatly increasing the so-called surface area of our code, where I come along and I look at your code base and I try and get a foothold and everything's split up into these tiny little units, these tiny little packets of code. Reading this kind of code often feels frustrating in the same way it can be frustrating to eat a bunch of little candies that are all individually wrapped. And when all your methods are really, really short, you end up having to jump all around the code to find any line of logic. A lot of business that otherwise could be neatly sequentially expressed in longer methods gets artificially split up. So it feels like you've taken a neatly sorted deck of cards and thrown them into the air so you can play 52 card pickup. Okay, so if you're not going to be writing object-oriented code, what are you going to be doing instead? You're going to be writing procedural code, but what does that look like? Well, as I mentioned at the beginning, this doesn't necessarily mean you need to avoid classes entirely. If you have a language like Python or C++, where you have both straight functions and also classes, there are some cases where the association between your data types and certain functions is really, really strong, that it fits some organizational purposes to just explicitly associate them together by making those functions methods of that type. The most obvious example would be ADTs, abstract data types, things like queues and lists and so forth. The key thing to keep in mind, however, is that the moment you start hemming and hawing about whether this particular function really has a primary association with that data type, that should be the moment you say, screw it, we'll make it just a plain function. Because it turns out that most things we do in code tend to be cross-cutting concerns. They don't have necessarily special, obvious relationships with particular data types. They might concern more than one data type. And that's why you should generally prefer functions, so you don't have to play this silly game of matchmaking functions to data types. So we're going to be writing our code primarily out of plain functions, and we're not going to attempt to encapsulate the state of our program at a fine-grained level because it doesn't work. However, shared state is still a problem, and if we're not careful, it can get out of hand. We can't totally solve the problem unless we do pure functional programming, but short of that, there are broad guidelines we can follow to mitigate the problem. First off, when in doubt, parameterize. This means that rather than passing data to functions through global variables, you should instead make that data an explicit parameter of the function so it has to get explicitly passed in. As much as possible, we want data access in our program to flow through the call graph. So anytime you're tempted to pass data to a function through a global because it seems more efficient or maybe just more convenient, you should give that a strong reconsideration. Secondly, whatever globals you do end up with in your program, it can be slightly helpful to group them logically into data types. Even if this means you effectively have a data type with one instance in your whole program, this little trick can often make your code seem just a little bit more organized. In a sense, you're just using data types this way to create tiny little sub-namespaces. But if you do a good job logically grouping your globals this way, as a side benefit, this can complement rule number 1, because now you can more conveniently pass this global state to functions. By bundling your data together into types, you typically cut down on the number of parameters which functions have to take. Though do be careful, there is an art to how you logically group things together. The third guideline is to opportunistically favor pure functions, even if you're not explicitly working in a functional style or working in a functional language. If you see an opportunity to make a function pure, it's generally a good strategy to take that opportunity. Again,
I'm going to make a comment on this real quick. One of the things that I always do is if I'm building a web application and I need to build out some function to maybe capitalize a word, especially like if we're pulling data out of a database and it's all been converted to lowercase just for the sake of normalization, instead of building that functionality inside of the component that needs it, I'll create a function that will capitalize a word, and I'll abstract that out into a folder called services, and then I might have a file inside of that folder called like string formatting.js, and then I'll import that into the component that I'm using. So I really like number 3, favor pure functions. If you can ever make a function so that it'll work all over the place instead of just in one place, I don't think it's a good idea to have that also encapsulated. If you could sort of globalize that, I think that's almost always preferable. So this is a big one that I really like.
and pure functions tend to come in at efficiency cost, but the brilliant thing about pure functions is that they're the only truly self-contained unit of code. When I'm reading and writing a pure function, I don't have to think about anything else. I can just consider that function entirely unto itself. Therefore, they tend to be easier to understand and to make correct. The fourth guideline is that we actually should try to encapsulate our code, only in a very loose general sense at the level of namespaces, packages, modules, whatever your language has. So when I'm working in Golang, for example, I think of each package as having its own private state and then a public interface. I find that encapsulation at this coarse-grained level tends to work because you're typically dealing with much larger units of code than the supposedly ideal classes of object-oriented programming. The typical Golang program is going to have not that many packages, maybe like 10 at the high end, and structuring a mere handful of elements into a hierarchy of encapsulation is reasonably doable. When it turns out during development that, oh wait, I have some cross-cutting concern of my packages, and so we're going to need to violate this perfect hierarchy of encapsulation, again, it's not such a big deal because you're dealing with a relatively small graph of objects. All the basic problems of encapsulation are still there, it's just at the coarse-grained macro level, the problems are reasonably manageable. The last guideline is that you shouldn't be scared of long functions. For a long time now, programming students have been advised to, when in doubt, chop their code into smaller and smaller functions. But doing this has significant costs. There are trade-offs. It turns out that most programs have these key sections where most of what the code is doing is a long laundry list of stuff. And what we're told to do in these scenarios is write functions like this, where all the business has been extracted out to separate functions. The problem with doing this pervasively is that what was naturally a logical sequence of code and was otherwise written in sequence, top to bottom, is now spread and out of order throughout your code base. Obviously, in cases where the business extracted to a separate function is something that you want to call in multiple places, that's a very good reason to have a function. But if all these functions were just called in this one place, I would generally prefer looking at code where the business of those functions is just done in line. And if we want high-level documentation of what's going on in my func here, then you just put what I would call a section comment, denoting what each section of the code does. In this arrangement, the sequence of the business is totally clear, and when I'm browsing the whole code base, when I'm looking outside this function, there's less clutter because there are now fewer functions I have to look at and wonder, well, hey, where is that called? I wonder what that thing does. It also has the advantage of letting
That's debatable. I mean,
Yeah, I agree. I
methods,
don't like that.
functions should only do one thing, and you shouldn't have a bunch of code doing multiple different things inside one function. It should be,
I tend to
spread
prefer
out,
this
like-
on the left side here. I agree. This, if there's anything in the video that I'm not huge on, it's what he's talking about right here. But I admit I personally will do this as long as it's not too long. So if we have a good example that I actually just went through was we're pulling data from Salesforce, the CRM Salesforce, and we needed to sanitize the data and save it into our database. And so I had one really long function that was in charge of normalizing the data. So making sure the dates were formatted, making sure the strings were changed to lowercase, making sure that some of the null values that couldn't be null were replaced with like an empty string or an empty object if it needed to be. And And I did have one sort of long function called normalize just because there were so many different things I had to do, but it wasn't so long that it was confusing or hard to read or disorganized. But I did notice, like, okay, a computer science teacher will probably hate this function, but normally I will opt for this type of thing. So is that what you're saying, that like you would prefer this over this? You still there, Kelvy? Okay, I think we lost you. I think you're muted.
If he's not going to speak, I would like to qualify a point that was made there.
Yeah, what is it?
I think.
Sorry, my sister was calling me.
Go ahead, Calvi.
No, you go ahead.
Yeah,
I didn't. I missed the last 30 seconds anyway.
Yeah, what were you saying?
Okay. Oh, sorry.
No, I'm just saying. Go ahead. I want to know what you were saying.
Yeah, the only piece of nuance that I would add here is which one I would go with would largely depend on testing and how easy it would be to test this function if it even requires a test, right? I think the one long function can pose problems depending on the surrounding architecture of the app some portion of the time, whereas the one on the left can be a lot more easier to test if you keep it to like a single responsibility principle. So it's one of those things where you just pick your poison based on context, I would imagine. It's not one broad thing.
And
yeah, I
there's
agree with you too, Marvin.
There's no one size fits all solution for any of this stuff, right?
Agreed.
Okay.
Avoid having to name functions. Naming stuff is really important.
Oh, and on the topic of naming functions, I'm curious what you guys think about this. I give my functions and my variables sometimes very long, very specific names. I never want to use something that can be ambiguous or that people aren't going to... I want to make it so that when other people are maintaining my code bases, there's no question about what a certain piece of data or a certain function does or represents. So what do you guys think about that? Like, if you have a variable name and it's like user's first name from Salesforce, it's long, it's obnoxiously long, but I like it because I think that if you have it be ultra clear, your code is so much easier to read, almost like self-documenting. Any opinions?
For me, I mean, it depends on context, like Marvin said. I think, if I was just showing someone a piece of code that I really don't care, like just to show an example in order to like educate or ask, I would just make a random variable and don't care about the name. If it was like a test interview by a company or, or an exam or whatever, then I would care about the variable names. So it does depend on context for me.
Okay.
Yeah, I think with your example regarding your normalize function being like a one long function that just basically contains all the logic for doing that. And again, feel free to check me and hold me accountable on this, but I would be less, picky about the variable names in that context. If this normalize function or, whatever it's named is pretty clear about like what's going on. So I wouldn't like go out of my way to do that. I would just put first name if it's, already known that this normalize function is to normalize the data from Salesforce before it goes into the database.
Okay. Yeah, I guess if you can make your code self... Oh, yeah, go ahead.
Yeah, and so I'm sorry, I didn't actually address like kind of what you got at, like, or like the point you made, being as semantic as possible, unavoidably makes code more self-documenting. The depends here just comes from, is there some broader piece of the code that documents what this would be? And so like in the context of OOP, right, like if we have a service that's like, I don't know, the customer detail service, right? I don't think I would need to put, customer first name from Salesforce because I would, this is very like a presumptuous, but like I would assume that this customer detail service like deals with the customer information from Salesforce based off of that. So I wouldn't need to be so specific for anything that lives under that service, if that makes sense.
Yeah, absolutely.
So it just depends. I know that's like the least fun answer that we get for all this stuff, but I definitely agree with you. I would lend towards semantics, or more semantic than not.
Yeah. Okay. All right, so we've got about... Okay, we're only about 5 minutes from the end here, so let's just blow through this real quick, and then I'm really interested to know sort of, overall thoughts and feelings, if anyone has anything they want to share.
In code, but it's really, really hard to do well. And in general, I find it preferable if we can avoid naming entities as much as possible. In this arrangement, we don't have to think hard about what to call these functions. We can just have a comment line and have a full English sentence, which generally is better at conveying accurate meaning and also is simply easier to write. If, for whatever reason, it doesn't seem adequate to simply comment a section rather than extract it to a separate function, the next best thing is to make it a private function, a nested function, such that it's clear this function is not called anywhere else, it's only called within this function. In this arrangement, I, as a reader of your code coming from the outside, I'm still presented with a smaller surface area, fewer entities in the code, and so it's just easier for me to get a foothold. Now, when you do write functions which are hundreds, if not thousands of lines long, you still should keep in mind general guidelines about code readability, basic things like not straying too far from the left margin for too far or for too long. You don't want to have code that's indented in 8 levels because it gets really obnoxious scrolling up and down code if you have to scroll over, for one thing. And also it tends to just imply there's a lot of busy logic in this part of code and it gets confusing. So likewise, you also need to look out for parts of functions where the logic's just getting too complex. The first thing to do is, of course, to try and simplify your logic, but failing that, there are going to be cases where, hey, we should just split this off into a separate function so it's more neatly self-contained complexity. The other concern with longer functions is that as your function gets longer and longer, you tend to accrue more and more local variables. So what you want to do is, hopefully your language allows this, you want to try and constrain the scope of the local variables so that they don't exist for the full duration of the function, but rather for subsections. This way, I, the reader of your code, when I scan up and down the function, I don't have to think about all the variables for the whole duration of the function. The way this is done in most curly brace languages is you can just introduce a new subscope with curly braces. So here, for example, this integer x variable only exists within these curly braces. When you have subsections of a function which you are commenting, it's generally a good idea to, when in doubt, enclose them in curly braces. This gives readers of the function an assurance that variables from the preceding sections don't fall through to the following sections. And so in later sections, we don't have to think about the variables that were used above. Where possible, the even better thing to do is to enclose these local scopes in their own anonymous function that's then just immediately called. And the advantage here within the nested function is that it's not just its own subscope, but also within this anonymous function, it's guaranteed that any return is not going to return out of the enclosing function, it'll return just out of this enclosed function. And so we have a stronger guarantee that the logic of this subsection is self-contained from the enclosing function. Unfortunately, what I often really want when creating subsections of longer functions is a feature that doesn't exist in any language I know of. It's an idea I've only seen in one other place. It was Jonathan Blow in his talks about his programming language that he's making. And the idea is that we want something like an anonymous function which doesn't see anything of its enclosing scope. The virtue of extracting a section of code out to a truly separate function is that everything that comes into the function has to be explicitly passed to a parameter. It would be great if we could write inline anonymous functions with this same virtue. Specifically, what I would propose is imagine we had a reserved word use that introduces a block, and in the header of the use, we list variables from the enclosing scope which we want to be accessible in this block, but otherwise anything from the enclosing scope would not be visible. These listed variables, however, would really actually be copies of those variables. So if you assign to x or y here in this scope, you're assigning to x and y the local variables of this use block, not to x and y of the enclosing scope, which is the effect you get with a truly separate function, right? You assign to the parameters of a function. You're not modifying what was passed to the function, you're just modifying those local variables. That's the same thing we want in this use block. Furthermore, a use block should itself return values. So you use return inside the use block, and it doesn't return from the enclosing function, it returns from the use itself. The use is an expression, and so we can return values from this use and assign it to this variable a. So in effect, we'd have this block of code, which is as neatly self-contained as a separate function. However, it is written in line, and so it's very, very clear that, oh, this is a piece of code that's only used in this one place. You don't have to go look for it elsewhere. And also, we don't even have to give it a name. Instead, we can just put a section comment header before the use block, and that is generally much better for containing the actual intent of this block of code. If later down the line we decide that this block of code actually should be extracted to its own proper function, That's a very easy thing to do. You can have an editor convenience that does that for you automatically. It's already clear what the parameters and the arguments should be. All the programmer would have to do is provide a name for the new function. So anyway, it'd be nice if languages had this feature. Unfortunately, I don't know of anyone that does. But regardless, you shouldn't be so scared of long functions. They actually have their place in most code bases. At the very least, I hope I can get you to try procedural programming. It doesn't really matter what language you're in. If you're in Java or C#, you can write procedural code, you can break the rules. But if you've ever felt any of the paralysis that I've felt attempting to do object-oriented programming properly to square the circle, I think you'll find abandoning all those ideas and just reverting to procedural code to be a liberating experience. I can tell you from personal experience of having read these books that you don't need to read them. They don't have answers, they're not going to square the circle, and you're going to waste productive years of your life trying to live up to their ideals. I'm not saying there's nothing to these ideas. There are bits and pieces that have value. Test-driven development, for example, has some interesting ideas. There's value in testing. But that's part of the problem, is that kernels of good ideas have been taken to holistic extremes in a way that I think has been disastrous for the industry and certainly for programming education. There are very few solid holistic answers about how we should write code. We'd all be better off if we stopped chasing that chimera.
All right, so that's the video, but I personally really enjoy his videos. I think he's very articulate and, you know, very smart. But again, I don't think there's any one size fits all for any of these things. So I think the blanket statement of object-oriented programming is bad in itself is a bad statement. It's more like use the right tool for the job, and maybe object-oriented programming isn't the right tool for every job. You know, that's kind of my take on it, I guess. So
Right. He finished off. He ended off saying like it depends on the context of like what you're doing. You know, that OOP may be good or bad for you, but like his video title is just straight up OOP is bad.
yeah,
You know, so it's just like he has an agenda right off the bat, really.
right. Yeah, I think it would be really cool, at least with this server. I know I said this before, but I would really like to have some sort of like, I don't know, group project, or maybe like just some GitHub repo that anyone could kind of experiment or mess with. Maybe even something specifically for the Discord server, you know, like a repo to build some bots or some, I don't know, it's just an idea. So if any of you guys have any thoughts or ideas of like a project that might be fun to do together, I'm definitely open to ideas. I think it'd be really cool to see everyone's styles and where we're all at. And are you still here, Marvin?
I am. What's up?
What's your background? Have we talked about this at all? Like, are you currently working as a developer? Did you go to school? You know, what kind of brought you to where you're at right now?
Yeah, I'm completely. I mean, again, I can't remember how I ended up here in this particular Discord, but I have enjoyed this first interaction here. Briefly, I'm self-taught, did not go to school for computer science or anything related. Actually dropped out of school 7 or 8 years ago, so I'm going to be 28 in a couple days, actually. I am a software engineer at a company called TaskRabbit, which is an IKEA subsidiary. I've held a couple of software engineering roles before this. Oh, and I guess perhaps more relevant.
Stack do you normally work? Sorry.
Like in a professional capacity, I've pretty much either been in Ruby on Rails land or full stack TypeScript, and have used like Angular and React Native professionally. And then I guess the only thing else that I would say is relevant for people that are not professionals is I was a maintainer and for about 1.5 years, a core team member of the Odin project, which is an open source platform that has like a web development curriculum and whatnot. And I recently resigned from there.
Wow, that's impressive. So how long have you been writing code professionally now?
Not long, a little under 2 years.
Okay, so we're pretty much both in the same boat. We're both college dropouts who are self-taught and, you know, just got into it in recent years. So that's pretty cool. I mean, TaskRabbit, they're a big company. Like that's a reasonably prestigious job. You know, maybe what's that?
Yeah, it's so weird to me because I had never actually heard of them until someone in my network referred me there. But I think since the IKEA acquisition, like the platform has definitely grown to, be like that Uber for handiwork or whatever.
Yeah,
What's the thing? TaskRabbit?
yeah.
It's so weird how I run into people that have heard of it, but I had never heard of it until, I signed my offer not too long ago.
I used to live in Buffalo, New York, and I just moved to San Francisco like 8 months ago. And in Buffalo, I'd never heard of TaskRabbit, except I was watching that show, Dave, on FX, I want to say, and they mentioned it in one of the episodes. But I moved out here, and in San Francisco, everyone knows and uses TaskRabbit. Like you need your blinds fixed or you need a door installed. Like TaskRabbit's just the go-to for all of that stuff out here.
Yeah, it doesn't surprise me. That's cool though. That's really cool to hear.
And did you say that TaskRabbit is using Ruby on Rails?
Yeah, so I mean, it's like a TaskRabbit, Rails on the back end. We do have some other things going on, but and then like React Native or React for like the front end, because as we have a variety of like mobile applications as well as our main like client web application as well.
Okay, that's awesome. Well, I appreciate you joining the group. That's really cool. I'm guessing you probably found the group through a Reddit post, right?
Again, I don't really remember, but given that I don't remember, Reddit would be the most likely place, and here I am.
Yeah. Okay. Very cool. So, is there anyone here that has anything they want to talk about? Because as soon as the conversation winds down, I've got some other things I'm going to be running off to, but I'm happy to stick around and talk about anything that anyone wants to discuss for a little bit.
Question. So what will the next meeting be about?
I don't really know. I don't want to be like a dictator. I really want this to actually be like a proper group. So, if we don't already have a channel for like recommendations, which I think we do, but maybe I should organize it a little bit better. I'd like to know what everyone wants to do and work around that instead of just kind of coming up with these ideas that I have no idea if anyone's actually interested in. Do you have any thoughts about
Right.
what you'd like to do or be involved with or talk about or anything?
Yeah, I mean, like the whole point of, I think most people, they want a community, but not only that, I think people here are looking for mentorship as well, right?
Yeah,
If I'm not mistaken.
definitely.
And I'm also looking for that too, especially people who are working and have been working professionally in the field. I don't care if you're self-taught or not, I just trying to use this to my advantage to improve my coding and get a job eventually. Yeah.
Maybe a good idea
I don't
would
know
be,
that. Yeah.
I think a good idea might potentially be I can create some sort of form that anyone who wants to fill it out and share their opinions of what type of content or discussions they want to be involved with can sort of fill it out, and we can read the room a little bit, and maybe sort of come up with a list of different types of engagements we can have. Because I know everyone wants mentorship, and I've gotten like a lot of one-on-one messages from people who only want to talk one-on-one. And unfortunately, if I only have a few hours a week to like engage with this group, as much as I would love to meet with people one-on-one, it's going to be difficult unless I really limit how much time I put into that. But I'm noticing more and more experienced people keep coming in here by the day, and more people are offering to help with this. So I just created a bunch of roles. So I've got roles like JavaScript specialist, .NET specialist, C and C++ specialist. So as I start like learning who's who and what which people are good with specific technologies, I'll start trying to categorize things as much as possible so that we have like some subject matter experts that people can refer to. And if I'm not mistaken, I think that more experienced developers typically like helping like less experienced developers. I know I personally enjoy it, and I'm not even all that experienced, but like programming has just changed my life so much that I want to help other people do it because it makes me so happy. But I think that we'll kind of get that vibe, that mentorship type of vibe, as long as we get more people on board who are also interested in helping.
Yeah, I mean, not sure if you're looking for this. I'm just an individual, right? I definitely cannot offer support like in this context, right? But given that you have like limited time, if you ever want to have a dialogue about community management, how to not burn yourself out, and things of that nature, I'm happy to have that dialogue because again, coming from like Odin and being a maintainer there and being pretty active in the Discord there, which, it's not a small community as far as Discord, well over 60, 70,000 people. Definitely have a lot of like insight there that's, away from the technical side and just how to make sure that spend your time wisely so you don't emotionally get affected by how big this actually is.
Yeah, I appreciate that, and I'm gonna take you up on that because last year I did something similar. I had a Slack group very similar to this Discord, and I eventually got burnt out and just couldn't deal with it anymore. But I was also applying for jobs at the same time. I was taking classes, and it was just like too much going on. And that was even a smaller group than this. So
There's nothing wrong with that, and I think unfortunately for those looking for like mentorship and stuff, which is all very positive things. Again, he kind of alluded to people wanting to, help where they can because that does feel good for people. The amount of effort and resources it takes to do something like this, I think is commendable. So
Yeah.
I appreciate you for starting this.
Yeah, and I appreciate that you're willing to give me some pointers because I am very new to this. Real quick, as long as I have your attention, though, I've seen so many people talking about the Odin project recently. I'm shocked that I haven't heard of it because it seems like everyone is like going through some curriculum these days with it.
Slash, yeah, r/learn programming loves the Odin project for some reason that predates my time
I have
there.
a question for Marvin. How much of a factor was it, the Odin project, in terms of you getting that first job or whatever when you started the course?
So you mean as far as like me
How much of
going-
a factor was it in preparing you for the job, getting you the job? Because I definitely am interested in going through the Odin project myself. It's just sometimes I just like the HTML CSS part. Like I'm not that interested in. But I'm just asking you that question: if how much of a factor was the Odin project? What'd you say?
So speaking from my time there, it provided the fundamental or like foundational knowledge I needed and, a variety of projects that I could place on my resume. And that definitely, got me looks. I know that's not like the most robust answer. It's one of the most mature resources, I suppose, when you consider the Odin project, Full Stack Open, Free Code Camp, etc. And so, yeah, it's a good platform. I'm no longer associated with the organization, so I'm being, reasonably objective about this. But with that said,
I get it.
With that said, well, yeah. So with that said, my general advice is just stick to one resource at a time, if you will, and, put your energy into that if you're learning or leveling up, kind of in the same way that Bob just said that you should focus on one language. And I have a very perhaps hot take, but quite frankly, I would stick to either a singular language or if you need to learn another language on your roadmap, then do that. But don't do anything else until someone's paying you to do it.
Yeah.
Bottom line.
That's a really good point too, is that now that I'm employed, my employers will pay for classes and let me take classes on the clock if I need to learn something new for something they want me to do. But when I was before I started applying for jobs, I felt like I needed to learn everything. I felt like I needed to be some sort of expert in JavaScript and various frameworks and databases, when realistically, like, your job as a developer is just going to be problem solving most of the time. So if you can learn how to learn things efficiently, and if you can learn how to, like, Google things the right way and how to ask for help, with, like, articulating your words in the most convenient way so that people are going to understand what you're actually asking, I think those are the skills that really, like, turn you into a developer. It's, like, less about memorizing syntax than it is solving problems. Okay. Well, it's been fun, guys. I'm going to take off for the day, but I'll get some sort of form sent out later, and so I can try to, like, feel the room out and find out what people are actually interested in getting out of this community. But I want to thank you all again for actually stopping by and for interacting. This is it's cool that people are interested in this. So I hope you all enjoy the rest of your day.
Later, Bob.
All right, have a good one.
Thank you for your time, Bob.
Bobby.
All right.
Is your real name Bob?
My real name's Robert.
Or is that just a name? Oh, I see.
Yeah, Bob is a nickname for Robert. All right, guys. I'll catch you
All right,
later.
man. Thank you.
Yeah.
Take care.
All right, bye.